Hey everyone, welcome back to my channel Design Mention. In today's video, we will perform a static stress analysis in square bar 25 by 25 mm and having length 200 mm. So we will learn how to apply loads, fix supports, mesh the model and analyze the stress distribution like a pro. So first I will just enter in the part modeling to create a body. So here I'll just click sketch. I'll just select the axis and creating a square bar which having the 25 by 25 mm cross section and having the length around 200 mm. Okay, here you must have to apply the material to that body. So I will just define the body and here you can find the apply material. Simply you just click and select the steel material and here you have to apply that body and say okay. You can check your properties to applied material. So here you can apply the material isotropic material. Here you can find the structural properties such as Young's modulus, Poisson's ratio, density, thermal expansion, yield strength. So I'll just click OK, and here you always verify your material units. If it will mismatch, so our results totally messed up, guys. So before you applying the any loads and any values to the body, so please verify your units must be aligned to the result. So here our body is created and we are moving forward to the analysis. So here I will just click on start. Here analysis and simulations. So we have to create generative structural analysis. I'll just click OK. You can you are entering the analysis screen CATIA V5. So here this window is pop up. So you have to do structural analysis. I'll just click OK. Here you can see the body which we have applied a material steel and we have checked the material structural properties, and here this toolbar is important to do the analysis. Here restraint, loads, image, and this one analysis tool you can do the animate to our simulation, and this is the compute. You can compute the results of the means post processing of that compute will be work. So here I'll just click clamp. I'll just click here. I'll just select that phase which we have to fix and say okay. After that I will applied a distributed force. Here I will select loads and here you can see this line. I will just apply the force to the downward direction with respect to the z axis. So here you can see this is my z axis and I have applied the 100 kilonewton force at the end of that body. So I'll just see click OK. Now in finite element mode you can see nodes, properties, material and static cases. So here I will just go in the nodes and double click on that octitetrahedron mesh. So this is octitetrahedron means the shape of this meshing is tetrahedron. Here I will just apply 5 mm and say okay, this is the size of our meshing. So this part is equally distributed 5 mm by 5 mm area. Then you can see later this mesh now you cannot see. So our meshing is applied, our force is applied, and one end is fixed. So our physical means we have applied the enough so now next we have to do the analysis. So here I'll just click compute and I want all the results. So here I'll just keep it as okay and I'll just click OK. Now you can see here it will take some time. So now our analysis is done with having the 5 mm sizing. And next one, you can go in the image toolbar. Here you can see our deformation. Here this is the deformation of that square bar. And next one is we will check the one meshes stresses. So here you can see highest stress is generated at that point 6.61 e raised to 9. Okay, that's how you can do the analysis of the static analysis of that bar in the CATIA. So here by double clicking you can go and check the results in details to the each point like this. And you can do simulation also to animate that video. So here in analysis tool you can just animate, click on animate like this. You can change the speed also. Okay, that's it from my side. If you have any issue, please do comment. And this video is really found helpful. Please uh, don't forget to like, subscribe, and share this video to the design bubbles. So thank you guys. Thanks for watching.